Okay, in this video we're going to wrap up section 6.5, and that's the graphs of the other trig functions. We're just going to get rid of the last two that we haven't seen yet, secant and cosecant. So you can read this on your own. It just talks about them being reciprocals and having some, asymptotes, just like tangent and cotangent functions. Here's the important stuff. To sketch the graph of secant or cosecant, you should first make a sketch of its reciprocal. For instance, to sketch the graph of y equals cosecant x, first sketch the graph of its reciprocal sine x. Then take the reciprocals of the y coordinates to obtain points on the graph of cosecant x. And here, if we look at it graphically, the real light gray line here is sine. We start at the origin, 2 pi later we're back at the origin, cross in the middle. Any time that the x-axis is crossed by the sine wave, that is a divide by zero scenario for the cosecant function. So wherever the sine wave crosses the x-axis, we have these asymptotes at the y-axis and every pi radians thereafter. And then to actually graph the cosecant function itself is, at the top of a sine wave, at a max value, we have our point, and then we have a parabola opening up. When we are at a minimum value for the sine wave, here in negative y territory, we're going to have at the bottom of this valley or a min value, we're going to have a parabola opening downward. So the period, just like the sine wave, is 2 pi. Its domain is all x values except the whole pi's. 1 pi, 2 pi, 3 pi, 4 pi. That's what the n stands for. The range is a disjointed set. All numbers except the numbers between 1 and negative 1. So from 1 all the way to infinity, or from negative 1 all the way to negative infinity. And we have our asymptotes at every n pi radians, symmetric about the origin. If we flip over secant, we get cosine. So here's our cosine wave. It usually starts here at a peak or top of a hill. 2 pi later, it's at another hill. In between, at pi radians, we're at the bottom of a valley or a min value. And just like the sine wave, wherever it crossed the x-axis, wherever cosine crosses the x-axis, we have our divide by zero scenario. So we have asymptotes at those points. At the top of our hills, we have a parabola opening upward. At the bottom, in these minimum value or value valleys, we have parabolas opening downward. So let's dive in here in example 4. Sketch the graph of y equals 2 cosecant of the quantity x plus 1/4 pi. To begin, we sketch the graph of its reciprocal. So we're just taking that cosecant and changing it to sine. Let's graph 2 sine of x plus pi over 4 radians. So here, the period is 2 pi divided by the 1 that's in front of the x value, so our period is 2 pi. And this has been shifted to the left 1/4 pi radians, so a leftward shift of 1/4 pi. Okay, sine usually starts at the origin, but we've been shifted to the left to 1/4 pi negative. We usually end 2 pi later, but that ending point has also been shifted. Now this is negative 1 3/4, or would that be negative 1 3/4, negative or 7/4 pi. We usually have an x-intercept at pi radians, but that's been shifted over to 3/4 pi radians. Everything shifted to the left 1/4 pi. So these are our sine wave, and this goes to a higher low of 2. Put it right about there, 2 and negative 2. So I'm going to graph the sine wave in light green, because this isn't really what we want. We want cosecant, but we got to graph sine to get there. So in the middle here, we're going to have a peak, and in between our two x-intercepts, these other two x-intercepts will have a valley. So here's our sine wave. And again, wherever we cross the x-axis will be an asymptote. So here at negative 1/4 pi, and at 3/4 pi, and at 7/4 pi. So I'll graph what we actually want here in red, and that is the cosecant function. The green line is the sine wave. If we want to graph the cosecant, we'll go from this max value here. We'll have a parabola opening up, approaching its asymptotes. Here we have a minimum value, and from this minimum value we'll have a downward opening parabola, again approaching its asymptotes on the left and right side. Example 5, sketch the graph of y equals secant of 2x. So if we want to graph secant, its reciprocal is cosine. So first we're going to graph y equals the cosine of 2x. And this has a period of 2 pi divided by 2, or pi radians. So we're going to graph cosine with a period of pi radians. Come out here will be pi. And we'll chop that in half, and these will be the quarter marks. And what the heck, let's go that far on the negative side also. Negative pi. Here's our negative half, and we have our quarters in the middle. And it's a 1 secant 2x, so we'll have our highs and lows for our cosine wave at 1 and negative 1. And I'll do cosine again in light green. So we usually start at a max value. We're going to end pi radians later on this at another max value. In between we'll have mins, or a min at pi over 2. And the important part here will be at the quarters. Here are our x-intercepts. So if I lightly graph this cosine wave, and let's do it to the negative side also. And we'll have our intercepts at the quarters. Okay. Red for the asymptotes. Wherever we cross the x-axis will be an asymptote at these quarter pi radian marks. Okay, and for the actual secant graph, from this minimum value we'll have a parabola opening down. From this max, a parabola opening up. And from this min, a parabola opening down. There's our secant of 2x graph in blue. So 3 Huddle problems to wrap it up. 2 on this page, 1 on the next. Pause the video, try the Huddle problems, come back, see how you did. So for the first one, negative a half of secant x, so we're going to graph negative 1/2 of cos x. And that's just the basic cosine function with an amplitude of 1/2, and it's a negative cosine. So we're going to go here, this will be our half and negative a half. The cosine wave is going to have a period of 2 pi. In the middle, we're going to have there's our halfway point and our quarter marks. So here, it's negative cosine, so we will start at a minimum value, 2 pi later be at another min, max in between, and we cross at the quarter pi marks. And might as well do that to the negative side also. So we're at a minimum value, 2 pi radians later we're at another min, max in the middle, x-intercepts in between. So from here we find our asymptotes. Any x-intercept of cosine is an asymptote of secant. So there's our asymptotes, and we use blue for the actual secant function. So parabola opening up, parabola opening down, and another one opening up. For the next Huddle problem, cosecant, its reciprocal is sine, and that's x over 3 or 1/3 x. Sine usually has a period of 2 pi, but we divide by our b value, which is 1/3. So here we are going to have a 6 pi period. And let's see, sine starts at the origin. 2 pi later we're done, x-intercept in the middle, and our coefficient in front of cosecant is 1, so we'll go from a high and low ones and negative ones. So there's our sine wave, and let's just do one more loop over here. That should be good enough, and we can find some asymptotes at our x-intercepts. There is one right on the y-axis, and every 3 pi after. So from our minimum values, we have parabolas opening down, max values, parabolas opening up. There we go. Last Huddle problem, we got another secant. So this is going to be pretty much the same as negative 2 cos of 4x. Cosine has a period of 2 pi divided by the b value of 4, or a half pi radians. And this is negative. So we can come out here to a half pi and chop that in half. That'll be a quarter pi, and then we'll have eighths, 1/8 and 3/8 will be right there. And let's at least go to negative a quarter pi on the other side. Amplitude of 2. And our cosine wave, since it's negative, we'll start at a minimum value. Half pi later at another min, max in the middle, and we're crossing at the 1/8 and 3/8 mark. And maybe let's go. And here we are again, minimum value. In the middle we'll have a max, and we'll cross at the 1/8 and 3/8 and negative pi radians. Alright, x-intercepts turn into asymptotes. And from max values, parabolas opening up. Minimum values have parabolas opening down. And there's our graph of negative 2 secant of 4x. Homework for this section is numbers 1 through 6 all, 12, 14, 17, 21.